G'day, Lance from Motive Power back again to talk a little further about off-highway vehicle design. But today we're going to stay a little bit away from the technical side and talk about costs, because quite frankly, everybody's interested in the costs. So far in this series, we've talked about the technical side of things, but costs will come in at some point, if for no other reason than you need to make your vehicle cheap enough to sell. And whether you like it or not, no matter how good you make the vehicle, it has to be at a price point that a number of customers can accept. While you're doing the design and selecting components, no doubt you're also asking for the cost of those components. And hopefully you're looking at alternatives that might present better pricing models for you. But there's some overall impacts on costs, if you like, at a strategic level rather than a tactical one, that I want to cover today. We all know that generally costs go up with size. A 6-cylinder engine is going to cost more than a 4-cylinder engine. But the problem is, it's not a linear function. They don't go up at a steady rate. They go up in steps, and that's the difference. I'm going to focus today on driveline, because that's where the biggest costs are. Engine, transmission, axles, maybe wheels and tires, but engine, transmission and axles. In my working life, I've proved time and time again that if you're essentially assembling a vehicle from purchased engine, transmission and axles, your purchase costs will be about 80% of the total cost. And you'll have about 20% of labour to put it all together. I used to get hammered to get the labour content down, and for valid reasons. But I could take 25% out of the cost of labour, and I would only take 5% off the total costs. If you wanted to get your costs down, the place to do it is in your larger purchased items. So the costs of your major components will go up in steps. If you move from a 4-cylinder engine at this cost to a 6-cylinder engine, it'll be at that cost, and an 8-cylinder and a 16-litre and so on and so forth. And the engines will go up in different steps to the transmissions, to the axles. So you've sort of got to blend it all together and find an economic point with all three, and maybe other things. Clients generally have an impractical belief that if you're buying a truck with half the rating of another truck, the one with half the rating should be half the price. It doesn't work like that. To start with, you've got common costs. The driver's seat in the smaller truck will still be the same size and cost as the seat in the bigger one. The steering wheel's the same, the door latches are the same, and so on and so forth. So we've got a situation where general componentry probably doesn't vary in cost much with the size of the vehicle. Windscreen wiper, it's the same whether it's on a big truck or a little truck. But the major driveline componentry does move. It all moves up in steps and in uncoordinated steps. So I'm going to show you some examples. This is old work. I don't have access to the original documents, but I hope it will give you a good understanding of what I'm talking about. This is part of a spreadsheet, or a PowerPoint rather. The graphs on it have come off a spreadsheet. We're going to start here and look at transmission costs. And these would have been different models of transmissions from different manufacturers. This was done for aircraft towing tractors, so the x-axis is vehicle GVM, the y-axis is cost. And this one is an excellent example of the step function. This model will work right out to here, but then we need to step up to the next model, which will work to there, and then we need to step up to the next model. Where you want to be at the step is at the bottom of the step. Here, maximum performance for the minimum price. The difference between being here at the bottom of the step and at the top of the step is very little difference in performance, but a whole lot difference in price. And here's an engine graph. Different brands, different sizes, same function you'll see going up in steps. And one brand going up in different steps to another brand. Now, unfortunately, these graphs aren't really aligned, but the reality is that a step in engine doesn't necessarily correlate to a step in transmission. The chances are they're out of sync. And the axles go up in similar steps. What you end up with is something over here. I'm going to call this a base cost, and that's the driver's seat, the steering wheels, the air starter, the windscreen wipers, and all the stuff that goes on the vehicle anyway. And the combination of all of these steps is going to end up giving you an exponential curve. And there's your driveline cost. Put together, you end up with a curve here. Total cost there. And that point there is about where you want to stop. That point there is before the curve goes exponential. And the cost of a small amount of increased performance rises dramatically. You want to be here. You don't want to be up there. How do you get down here? Well, you come back and you look at your steps. And you say, well, if I drop 2 ton in GVM, I can drop to here. Big cost difference. Oh, and gee whiz, by the way, if we change from, say, Detroit diesel to John Deere engines, we'll get another cost saving, and so forth. This is an approach to help you manage costs, but you need to be aware of what's happening. These steps, it's very easy to get focused on the engine you want or the transmission you like, and forget what they're doing over here. If you can drop a couple of ton, in this case, and go from here to there, you will save a lot of money. Now, you'll save money, and maybe you'll make some extra money because your margin will be better. This approach has been great for me in explaining primarily to senior management why the vehicle ends up costing that much. And yes, we can make it cheaper, but you're going to lose performance because we're going to have to put a smaller engine in it. That performance might only be a little bit. Can marketing and sales accept that? You now have the basis, hard data, to make decisions. And of course, you can flip it on the people that are asking you the question and giving you the hard time, because you can say, well, here's my data, where's yours? And don't forget, coming down a step means lack of performance, loss of performance. That in itself needs to be said and sold. So again, this is a very good example of why you need to clearly understand the application, all the implications of it. Because you're going to have to make a decision. Can I come down a step? Does that reduction in performance still make a viable vehicle or not? And of course, all of this helps you select components and justify them. Vehicle designs, like anything else in engineering, are a compromise. I'm sorry, you can't have a Rolls-Royce car for the price of a Chinese cherry. It's not going to work. Managing the cost of your design is just as important a part of the design process as selecting the componentry is. They should be done together, parallel. If you're a professional engineer, you'll use these tools to make sure that you're making the right decisions and to explain it to others. You might not need it, but it's a damn good way of showing your management that you're on top of your game, you've got all the figures under control, and you've done the best job you can. So as usual, crunch the numbers, do the analysis, draw some pretty graphs, prepare yourself for the discussions that should happen around costs and benefits for your design. Remember, you can pick any two of good, cheap, and quick, and you shouldn't sacrifice good. This will help with those discussions as well. Remembering that cheap and quick usually ends up costing more in the long run because you've got to fix warranties. Do all of this analysis, make sure you have it nailed and you can justify it, and then you can confidently move on to the rest of the design work. See you next time.